Hello everyone. Today we are going to solve one of the very important question from the eigen values and eigenvector chapter. Eigenvalues and eigenvector we need to find out, and we are given a matrix of 2 cross 2. Whenever we get these kind of question, first we need to know what is a characteristic equation. Characteristic equation is determinant of a minus lambda I is equal to 0, where A is a matrix, where A is a matrix, lambda is a scalar value, and I is a identity matrix of 2 cross 2 in this particular question. Okay, it is of 2 cross 2. Now what we will do, we are going to consider A is equal to given matrix 1, 2, 3, 2, and here we do not know what is value of lambda. Lambda is actually a eigenvalues. We need to find the eigenvalues from the lambda, and for that what we are going to do is we need to substitute a into this one. So what we are going to have 1, 2, 3, 2 minus, okay, minus lambda into 1, 0, 0, 1. Just look at this. This is actually identity matrix of order 2 cross 2, and this is going to be equal to 0. And this implies, see, this is going to imply 1 minus this lambda is multiplied to this whole matrix, so it is 1 minus lambda, okay, and 2 minus 0, 3 minus 0, and then 2 minus lambda, and this is equal to 0. This implies, now we are going to multiply, we are going to simplify it first. 1 minus lambda, 2, 3, 2 minus lambda is equal to 0. And now we'll solve the determinant. We are going to multiply this and this minus this and this. That is known to you all. 1 minus lambda into 2 minus lambda minus 2 into 3 is equal to 0. Okay. This implies 1 into 2, 2, 1 minus lambda minus 2 lambda plus lambda square minus this one 6. This is equal to 0. This implies, just I am going to rearrange this, lambda square minus 3 lambda minus 4 is equal to 0. Here we are going to factorize this and find the value. Otherwise you can use the quadratic equation that is left to you. Let me find using the factors plus lambda. See, when you solve this, I should be able to get this. Minus 4 is equal to 0. This implies, from this both I am going to take lambda is common. Lambda minus 4 plus lambda minus 4. From both of these, we have got lambda plus 1 into lambda minus 4 is equal to 0. This implies lambda is equal to minus 1 or lambda is equal to 4. And therefore, we are going to find now the eigenvectors. These both are eigenvalues. Just remember the procedure. Whatever you will be given a matrix and you will be asked to find the eigenvalues and the eigenvectors. First you are going to find eigenvalues. that is the value of lambda. To find the value of lambda, you are going to consider the characteristic equation, that is determinant of a minus lambda I is equal to 0. A minus lambda I, this comes from the definition itself. And now if you look at this, A is equal to the given matrix, and just substitute the values and find what is lambda by solving the determinant. And now we have come to solve, to find to find eigenvectors. To find eigenvectors, you see, to find eigenvectors we have got two values of lambda. One is lambda is equal to 4 and lambda is equal to minus 1. First consider lambda is equal to 4 and we'll try to solve the answer. We'll try to find the required vector. Consider the same equation, a minus I lambda. Okay, we can use this equation. Here I am going to substitute, but to find the vector we are going to write the complete equation. Okay, let me erase it once. Okay, now we know that a minus lambda I into vector is equal to 0. We need to find this particular vector. For that already we have got the value of lambda. Here lambda is equal to 4 and we have got already what is a. Let me write a is equal to here. A is equal to 1 2. A is equal to 1 2 1 2 3 2, right? 1 2 3 2. Now we'll go to the next part where we substitute value of lambda. Here we have got 1 2 3 2, okay, minus lambda is 4 1 0 0 1, okay, and the vector is equal to 0. Just I have substituted the values. This implies now I am going to get 1 minus 4, okay. You see carefully, 1 minus 4, this minus this, 2 minus 0, 3 minus 0, and then 2 minus 4, okay. Vector is equal to 0. This implies minus 3 2 3 and again minus 2, and the vector is equal to 0. Now in order to find the value of this vector, let me consider is equal to v1 and v2. You can do this, there is no problem. What we can do is this implies minus 3 3 2 and minus 2, and we are going to get v1 v2 is equal to 0 0. Now what you do, just multiply minus 3 to v, minus 3 v1, okay, plus 2 v2 and 3 v1. Just multiply this and this vector, and minus 2 v2, and this is going to be equal to 0 0. Therefore here we got two equations. One is minus 3 v1 plus 2 v2, this is equal to 0. So This implies minus 3v1 is equal to minus 2v2. This implies 3v1 is equal to 2v2. This is from first equation. And from second equation 3v1 minus 2v2 is equal to 0. This implies 3v1 is equal to 2v2. See, from both of them we have got the same value. So what I can do is I can write v1 is equal to 2 and v2 is equal to 3. Okay, these values can satisfy this equation. Therefore I will have vector v is equal to 2 and 3. So this is going to be our first vector. So this is our first vector. Okay, now coming to the next part, means this was when lambda was is equal to 4. Now coming to the next one, when lambda is equal to minus 1. Lambda is equal to minus 1. We are going to have a minus I lambda is equal to vector is equal to 0. Now substitute value of lambda. This is actually lambda minus 1. So it is going to become a plus lambda I after substituting value of lambda. Okay. A plus I vector is equal to 0. This implies I have substituted value of lambda as minus 1 and therefore I got it as plus. And now we know that value of a is equal to 1 2 3 2 1 2 3 2 plus 1 0 0 1, and this is going to be a vector here is equal to 0. This implies we are going to add both. Here we get 2 2 3 3. Okay, and for v I'll be writing it as v is equal to v1 and v2. So it is v1 v2. This is equal to 0. This implies 0 can be written as 0 and 0. Now you just multiply 2 v1 plus 2 v2. This is just a multiplication. 3 v1 plus 3 v2. This is equal to 0 by 0. And this implies 2 v1 plus 2 v2 is equal to 0. 3 v1 plus 3 v2 is equal to 0. Therefore v1 plus v2 is equal to 0, and again v1 plus v2 is equal to 0. You are getting the same thing, and that's why we are going to have, there will be many values. You can have one of the value v1 is equal to 1 if I write, v2 will be equal to minus 1. Okay, or therefore I have got this vector as 1 and minus 1. So these are the two vectors. Okay, therefore eigenvalues, required eigenvalues are 4 and minus 1. Eigenvectors are 1 I have got here, 2 2 3 2 3 and 1 minus 1. This is the solution for this equation. Okay.